Hello, and welcome to Lesson 11.6, Solving Quadratic Equations by Using the Quadratic Formula. Our objective for today is that I can solve quadratic equations by using the quadratic formula, and I can use the discriminant to determine the number of solutions to a quadratic equation. So, we've gone through a couple methods of solving equations thus far. We have done solving equations by graphing. We found that to be tedious. We found that to be challenging if we didn't have nice whole number or nice easily graphable functions. We did by factoring, factoring with an a of 1, factoring with an a value of not 1. We found that those were challenging sometimes, but there are some functions that we found were not factorable. We could not find factors that multiplied to what you needed to that also had that sum. Or there were ones that we just didn't know what our factors were originally, and they're kind of tough to have to find. So we're going to try to find a method that is going to be usable for absolutely every quadratic function out there, and it will accurately tell you if there's a solution, how many solutions there are, and what they are. So we're going to do the quadratic formula today. Now, the quadratic formula you see laid out in front of you here. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, where have we seen? We've seen parts of this already, right? This opposite of b over 2a part. We have seen that because we use that to find the axis of symmetry. And what does the axis of symmetry represent for a quadratic? It represents the mirror line that we are reflecting across. It is the center. It goes through our vertex. So essentially what quadratic formula does is it takes that center point, and then we are going to add or subtract this square root of b squared minus 4ac. So using the a, b, and c values that are going to shift a graph up or down, that are going to move a graph to the left or to the right, and that are going to stretch a graph, all the stuff we did in the last module, all of these pieces come together here with this plus or minus. This is telling us we are going to move to the right on the number line a certain amount and to the left a certain amount because our solutions are going to be equal distance away from your axis of symmetry. So this is plus or minus this amount. We're going to the left or to the right, the same amount to get to where we are going to be hitting our x-axis. So let's look at it and let's start using quadratic formula. Quadratic formula is incredibly powerful when it comes to solving equations. Like I said, absolutely every quadratic function can be solved using quadratic function or quadratic equation formula, quadratic formula. Absolutely every quadratic can be solved this way. Now, there are ones that are going to be much easier to solve other ways. There are much easier ones to solve by factoring, but we're going to solve and we're going to use quadratic formula here. So, for example, this one right here, we've got an equation and we want to figure out what it is. We are looking for factors of 12 that add up to -8. That's obviously -6 and -2. But wait, we're going to figure this out a different way. We're going to use quadratic formula. You're going to see that quadratic formula is not necessarily going to be easier than factoring is. So we set it up. X is equal to the opposite of b. So the opposite of -8 is +8. Plus or minus the square root of b squared. So -8 squared minus 4 times 1 times 12. This is all over 2 times 1. So now my second line, we're going to do some simplifying. We have 8 plus or minus the square root. -8 squared is 64 minus 48. And it's all being divided by 2. All right, so my next iteration, we do our Simplification underneath the radical. 64 minus 48 is 16. And this is all divided by 2. And so now we have x is equal to the 8 plus or minus the square root of 16 is 4 all over 2. And now we split into our two equations. We do 8 plus 4 over 2, 8 minus 4 over 2. 8 plus 4 is 12 over 2 is 6. 8 minus 4 is 4 over 2 is 2. Now, way back at the beginning, I said we could factor this, and we absolutely can, right? This would factor to x minus 6, x minus 2 equals 0, and then we separate it, x minus 6 equals 0, x minus 2 equals 0, so x equals 6, x equals 2. Hey, look, those are the two same solutions. So quadratic formula will absolutely work for every problem that you can use it for. It's not always going to be your most efficient method. In this case, this problem, factoring is significantly more efficient than using quadratic formula. Quadratic formula is the brute force. I am going to pound my way through this equation. Other methods are a more finesse method where you are working your way through gaps and making it happen easily, as opposed to just brute force pushing your way through. So let's look at another example. Letter B. On the surface, I don't know factors of 36 that add up to 13. So let's just work with what we got. We're going to use quadratic formula. So we have the opposite of b. So negative 13 plus or minus the square root of b squared. So 13 squared minus 4 times 6 times 6 all over 2 times 6. All right, so we've got the opposite of 13, negative 13, plus or minus the square root of 13 squared is 169. 4 times 6 is 144, and this is all over 12. So x is equal to the opposite of b, negative 13, plus or minus the square root of 25 over 12. X is equal to negative 13 plus or minus 5 over 12, right? The plus or minus accounts for the fact that we have a positive and a negative value of the square root of 25. So we have negative 13 plus 5 over 12, negative 13 minus 5 over 12. All right, so negative 13 plus 5 is negative 8 over 12, which is negative 2 over 3. Negative 13 minus 5 is negative 18 over 12, which reduces to negative 3 over 2. All right. Now, when it comes to showing your work, what am I expecting you to do? What's the bare minimum? Well, the bare minimum is you're going to show the first step. You're going to substitute into quadratic formula. The 13 squared minus 4 times 6 times 6, you could collapse that and do that in your calculator and type that out as one string. So then I would want you to have this and this shown. And then that leads you to your final work. So really, if you wanted to skip that green step there of showing me the two terms before you subtract them, you could. I do want you showing me what you're taking a square root of, though, because that's going to help me identify if you've made any mistakes. All right, let's take a look at letter C. We've got x is equal to, well, wait a minute, this isn't in standard form already, so we need to get it there. So it's going to be 2x squared minus 5x minus 3 equals 0. right? We subtracted 5x and subtracted 3 from both sides. That's first semester work. I'm not going to show it to you. So the opposite of b, so the opposite of negative 5 is positive 5, plus or minus the square root of negative 5 squared minus 4 times 2 times 3 all over 2 times 2. So my second step, we have 5 plus or minus the square root of 25 plus 24, all over 4. Simplify inside the radical, 5 plus or minus the square root of 49 over 4. X is equal to 5 plus or minus square root of 49 is 7 over 4. And then we break it apart. We have 5 plus 7 over 4, 5 minus 7 over 4. So we get 12 over 4, which is 3. We get negative 2 over 4, which is negative 1/2. All right, time for you to try letters D, E, and F on your own, and then check your work against mine. Letter D. We have the opposite of 7 plus or minus the square root. 7 squared minus 4 times 1 times 12, all over 2 times 1. X is equal to negative 7 plus or minus the square root of 49 minus 48, all over 2. X equals negative 7 plus or minus the square root of 1 over 2. The square root of 1 is 1. So negative 7 plus or minus 1 over 1. That we then split into our two equations. Negative 7 plus 1 over 2. Negative 7 minus 1 over 2. Negative 7 plus 1 is negative 6 over 2, which is negative 3. Negative 7 minus 1 is negative 8 over 2, which is negative 4. Letter E. We have x is equal to negative 5 plus or minus the square root of 5 squared minus 4 times 2 times negative 12 over 2 times 2. So we've got negative 5 plus or minus the square root of 25 plus 96 all over 4. Simplify inside the radical. 25 plus 96 is 121 over 4. Square root of 121 is 11. And then we need to split it. Negative 5 plus 11 over 4. Negative 5 minus 11 over 4. So when we do the math, we've got 6 over 4, which reduces to 3 over 2. Go ahead and just leave these as fractions, guys. So we have negative 16 over 4, which is negative 4. For solutions here, leaving it as a fraction is going to be your easiest method. If it is like the fractions that we've gotten so far, for the most part, except for the first solution in letter B, they have all been terminating decimals. So if it's a terminating decimal, I'm not opposed to you writing it as a decimal. If it is a repeating decimal, I absolutely want you leaving it as a fraction. So I want you leaving it as negative 2/3, not negative 0.6 repeating or negative 0.67. The reason for that is that when you leave it as a fraction, you are actually giving yourself a more accurate answer than if you were to round it off. All right, let's look at letter F. X is equal to the opposite of b, negative 10, plus or minus the square root of 10 squared minus 4 times 8 times 3. This is all over 2 times 8. All right. Next up, we simplify the multiplications inside the radical, and we get 100 minus 96 over 16. So negative 16, not negative 16, negative 10 plus or minus the square root of 4 over 16. Square root of 4 is plus or minus 2 over 16. We divide into our two pieces, negative 10 plus 2 over 16, negative 10 minus 2 over 16. So we get negative 8 over 16 on our first run, which is negative 1/2 when we reduce. We have negative 12 over 16 in our second run, which is negative 3/4. Again, leave these as fractions. Now, looking back up at the top for a moment, I'm going to just tell you right now. That right there is a question on your quiz. What is the quadratic formula? X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's a quiz question right there. That is also likely going to be a final question. So keep that in mind. Memorize that formula. All right, now going down to the bottom of the page, we have example 3, which is solving a quadratic equation with irrational roots. Well, what does it mean for it to be irrational? Up until now, all of our square roots that we've been taking have been perfect squares. That is not going to be the case anymore. So if we're looking for a square root of a non-perfect square, it is going to be a irrational number, and we are going to have to round at some point. Now, what I want you to do is hold off on rounding until the very last step. And we're going to leverage our calculators and use them to our advantage. So we're going to set it up the same way, though. We've got the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2 times 4. So we have negative 7 plus or minus the square root of, we've got 49 minus 32, and that is all over 8. Negative 7 plus or minus the square root. 49 minus 32 is 17 over 8. So this is where normally we would take the square root and split it. We're going to split it now. So we're going to split it in a positive and a negative direction. So we're going to do negative 7 plus the square root of 17 over 8. We're going to do negative 7 minus the square root of 17 over 8. So when you do the addition one, you're going to get a negative 0.36 rounded. When you do the subtraction one, you get negative 1.39 rounded. So make sure when you're typing this in, you're going to type in the numerator, negative 7 plus the square root of 17, and hit enter. Then divide that value by 8, and then round. Right, so I want to save our rounding to be at the very last possible step. All right, so letter B, we've got Greg tosses a baseball across the playground, and the ball can be modeled by the equation y equals negative 0.005 x squared plus 0.75 x plus 4. X is the horizontal distance in meters from Greg, y is the height of the ball. How far from Greg does the ball land? All right. So we set it up the same way. Negative 0.75 plus or minus the square root of 0.75 squared minus 4 times negative 0.005 times 4. And this is all over 2 times negative 0.005. All right, so let's do the simplification. Negative 0.75 plus or minus the square root of 0.5625 minus plus 0.08. And this is all over 0.01. Negative 0.75 plus or minus the square root of 0.6425 over 0.01. And now we split it into two equations. Negative 0.75 plus the square root of 0.6425 over 0.01. And when I do that calculation, I get negative 5.16. My second one, negative 0.75 plus, not plus, minus the square root of 0.6425, and divide that by 0.01, and I get 155.16. You'll notice I'm rounding to the hundredths place. I think that's a pretty reasonable place for us to measure. Now, this is a real world scenario, so now we need to ask ourselves, which of these values makes the most sense? Does it make sense for Greg to have thrown the baseball and for it to go 5 feet behind him? Or does it make sense for it to go 155 feet in front of him? It is the latter. And so 155.16 is going to be your answer in feet of how far Greg managed to throw that particular baseball. All right. So let's look at the next page. 2 U-try problems that you need to do on your own, and then you are going to check your work against mine. Letter C, we start off. It's already in standard form, so we have x is equal to the opposite of b, so positive 13, plus or minus the square root, negative 13 squared, minus 4 times 3 times 7, and this is all over 2 times 3. We've got 13 plus or minus the square root of 169 minus 84 all over 6. 13 plus or minus the square root of 85 over 6. And now we split. We have 13 plus square root of 85 over 6. And when we do that, we are going to get 3.70 when we round. We're going to get 13 minus root 85 over 6. And when we do that one, we get 0.63. All right, letter D. We've got the normal blood pressure of an adult woman, P, in millimeters of mercury, given her age, T, in years, can be modeled by the equation P equals 0.01 T squared plus 0.5 T equals 107. If Seiko's blood pressure is 120, how old might she be? So we're going to substitute in 120 for the pressure. So when we do that, I'm going to do it up at the top here. 120 is equal to 0.01 T squared plus 0.5 T plus 107. That's a plus sign there. That didn't get fixed. So plus 107. So then we subtract 120 from both sides, and we get 0 is equal to 0.01 T squared plus 0.5 T minus 13. Where'd my 1 go? There it is. All right, so that is our quadratic formula that we are going to be solving. So x is equal to the opposite of b, negative 0.5, plus or minus the square root of 0.5 squared, minus 4 times 1, or 4 times a, which is 0.01, times c, which is negative 13, all over 2 times 0.01. So when we fix this, we get x is equal to negative 0.5 plus or minus the square root of 0.25 plus 0.52. And this is all over 0.02. Combine it, we've got negative 0.5 plus or minus the square root of 0.77 over 0.02. And we split this now. We got x is equal to negative 0.5 plus the square root of 0.77 over 0.02. And that's going to equal 18.87. Our second one, negative 0.5 minus the square root of 0.77 over 0.02, that's going to equal negative 68.87. Which of these is our reasonable solution? It is our first one, because you can be 18.87 years old. You cannot be negative 68.87 years old. All right, so our last bit here is to use the discriminant to find the number of solutions. So the discriminant of the expression is what is underneath the radical sign in the quadratic formula. It is this portion of it right here, b squared minus 4ac. That is going to determine how many real number solutions we have. If that value is less than 0, there are no real number solutions. We are shifted up. There is no point in that graph that is going to intersect with our x-axis. If the discriminant b squared minus 4ac is equal to 0, if that equals 0, there is one real solution, and it's at the vertex. Lastly, if b squared minus 4ac is greater than 0, there are two real solutions. You will be expected to write the formula for the discriminant on the quiz. You will be expected to apply the discriminant on the quiz. But let's think about this logically. This piece is under the square root. So if it's less than 0, that means it's a negative number. Can we take the square root of a negative number? Not in Algebra 1 and not dealing with real number solutions. So that is why there's no solution there. If we're taking the square root of 0, the square root of 0 is 0. So we're going to add or subtract 0. So we are at the vertex, right? Opposite of b over 2a, that part of the formula is the vertex, the axis of symmetry, right? So if we are saying that we are adding and subtracting nothing from that, then we must be at the vertex on our x-axis. And lastly, if it's positive, we are taking the square root of some number, so you will have a plus and a minus. We are moving to the right and to the left of this value, so it's got to be something. So it's going to be two solutions. So let's look at letter A. We're going to rewrite that. That's going to be minus 7 equals 0, right? Once we subtract 7 from both sides. I'm not going to show that. That's first semester work for you. So b squared, negative 5 squared, minus 4 times 6 times negative 7. We've got 25 plus 168, which is 193. We have two solutions. Take a look at letter B. X squared plus 7x plus 13 is equal to 0. So first off, 7 squared minus 4 times 1 times 13. So 7 squared is 49, minus 4 times 1 times 13 is 52. So I get negative 3. No solutions. There are 2 U-try problems, C and D. Do them on your own and check your work against mine. For letter C, we have negative 4 squared minus 4 times 3 times negative 10. So negative 4 squared is 16. 4 times 3 times negative 10 is plus 120. So that's 136. We have 2 solutions. Lastly, letter D. We've got b squared, so 4 squared minus 4 times 2 times 2. So that's 16 minus 16, which is 0. So this is 1 solution. And there you have it. That is the quadratic formula and the discriminant, 2 of the most powerful formulas that you are going to learn in Algebra 1. That's all we have for today. If you have any questions, please bring them to class tomorrow. Otherwise, I hope you have a great day.